The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. I am Ahmed Lashin, a lead application engineer in Center Innovation. And we have Peter Sifont on the line as well, who is the production manager at Zenas. I will start the beginning of this webinar about SODOC's new features in 3D printing and 3D scanning, and Peter will give us inside ideas how they do design and stuff, and he will explain a lot more about his agenda soon. So the webinar topic today is about 3D metal printing and rapid prototyping. And here is our agenda today, but before we start, I just will make sure that you guys can hear me well and you can see my screen. Also, keep in mind that there is a question section in the GoToWebinar application where you can ask your questions, and we will get back to you at the end of the webinar. So if anyone is struggling in hearing me or seeing my screen, please write down in the question section or the chat section. So what we will discuss today, we will start by what's new with 3D printing in SolidWorks and the mesh modeling, new features. Then Peter will give us more details about how they are doing 3D printing and 3D scanning in Zentis. So I will start. Here's a presentation by the new features in 3D printing in SolidWorks. 3D printing has been added to SolidWorks since 2015 as a feature that allow you to print directly from SolidWorks, and has been enhanced a lot in the new versions up till 2020. So I will switch now to SolidWorks and show you more about this feature here. Okay. So there is a feature available in SolidWorks from File, Print 3D. Starting from 2020, the Print 3D option has a list of favorite or a list of most of the printers available in the market. So you can manage the favorite and search for your printer here. Definitely you will find it in the list. And if you can't find it, contact us and we will raise a request to SolidWorks to add it. So you will see all the printers, and once you select the printer, you will see the bed size, height, length, width. So you can identify if your design fits with your printer or not. So I already have two printers added to my favorite. I will select the UpPrint SE Plus. By defining the bottom plane for this part, SolidWorks can identify if this part can fit within the bed area or not, using offset geometry and OrientoFit. OrientoFit, SolidWorks will suggest the best orientation for it to fit within your printing area. It's not only limited to this, it's also give you more functionality about controlling the quality and infilling percentage. And also you can view the support, the faces that required support, and the striations lines. And also you can generate slices, which could be useful when you export the file as 3MF. 3MF is a new printing extension, which is an XML-based extension, 3D XML, that allows you to store, let me show you here in the Save As, 3D XML, 3DMF, Save As. So 3MF allow you to store material, appearances, and the slices information within the file. So your printer will recognize all of this data and you don't have to recustomize it again in your printer application. If you have your printer plugged in, then you can just print it from SolidWorks directly by clicking on Print Properties, where you can tweak and finalize your print options for your printer, then print directly from SolidWorks. So that's about 3D printing. The other enhancement I will talk about it here in SolidWorks is dealing with the scan data. Dealing with the scan data was a hassle for a long period of time, but starting from 2018, SolidWorks has added several features to a tab called Mesh Modeling, which allow you to manipulate the mesh files and do some changes in the mesh file, and even you can save it as another mesh file later on, or you can convert some of these meshes to be faces and solid bodies. What I'm talking about here is different than a scan to 3D module in the premium license of SolidWorks. Let me show you more in SolidWorks. I will open here a file that's available in my machine about mesh. Yep, direct editing. So that's the STL file. But before I open, we have to look at the options here to identify exactly what you're looking for to open. You would like to open it as solid or surface or graphic body. Graphic body will be just a graphic representation and you can't modify it, you can't do anything. Surface body, without checking this box, will deal with each and every facet of the mesh as a separate face, which will be a real pain for modification. That's why it's recommended, and the best practice actually is to use these options. I will show you now the result. So merging the facets to be one face will result that you can pick faces easily and do any changes you want instead of picking facets faces of the mesh. Starting from 2020, you can apply fillets. Let's say fillet 3 to this edge. You can apply fillets directly to the scan data. Yep, let's do just one edge for now. And even you can convert the mesh to a chamfer later on if you want, or even you can start with a chamfer. And also you can do some changes, like if I would like to change a mesh file, this cutout to be bigger or smaller, you can do offset surface. I will offset it by 5. Then I will use the surface regular commands tool to do trimming, definitely after extending the surface. Yep. Then we can use trim tools to do mutual trim between the two bodies by removing these two areas. Here we go. Now I did a major changes in my mesh file. I can export it back now as a mesh file or keep using it. Besides, the mesh modeling tool has several commands here, very useful to convert this mesh file to a solid body or surface body, like surface from mesh, which can generate a one single face out of mesh facets. Also, you can get rid of any holes by just right-click on it and delete hole, or just delete. Delete will delete the hole and close it. Oops, sorry, I should select delete hole. Yeah, you can select delete hole, and delete hole tool will patch the hole and close it. Or even you can use the mesh tools to do some modifications, like modifying the mesh geometry by deleting faces and patch it. Not limited to this enhancement, there is a lot of other enhancements that makes modifying mesh data easier than before. Going through the last topic I will cover today, which is mesh decimations, that allow you to reduce the amount of mesh facets to make dealing with the mesh data lighter in SolidWorks. This is one of the new features also available in 2020 to facilitate and allow dealing with mesh files easily. I will not spend too much time talking today about SolidWorks capabilities here, because we would like to give a chance to Peter to give us ideas about what they do exactly in Zentits. And yeah, so I'll move the mic now and the screen to Peter. Peter, could you please double check that your mic is working?
Yep, can you hear me? Can you hear me and see my screen?
Yes, we can.
Awesome. Thanks for the introduction. I'll just do a bit of a brief introduction and provide some context to, well, who I am and what we do. So I'm Pete from Zenith Technica. I've been with Zenith Technica for coming up to 4 years now, and we are a metal 3D printing manufacturer, and we specialize in building titanium alloy on electron beam melting machines. So well, I'm not going to go into too much detail about the process today, but I will show you a quick video of at least how it works, so that you have some context of what we're talking about. So let's quickly watch this. let's assume we've done all the CAD, we've got all the parts, and we're going to put them on the machine. So it's a powder bed based method, and we are building slices of parts or layers of parts. The machine has 2 hoppers, gravity fed onto a powder bed inside a vacuum chamber, and a rake will move the powder onto the bed. We preheat all of the powder and sinter it, and then we mount the layers of the parts. So this is a bit of a unique process in the fact that we sinter the powder before we mount the parts. So because we heat layer by layer, at the end of the build, we get a fully annealed part out the other end. But that also means that you've got a whole bunch of sintered powder surrounding your parts now. So we'll see in this animation, this keeps repeating, layer after layer after layer. The build comes out in a sinter block, and we have to take that to a blasting unit, and we blast with the same titanium powder that we built with, and we remove all of that sintered powder. And then we are able to take the parts out. So you'll see that in a second. Blasting, 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 and out come the parts. This is a real oversimplification of the whole process, but it's good to understand the high-level idea of how it works. So in terms of our CAD and our SOLIDWORKS uses, our day-to-day use is actually kind of boring because most of the time we previously to the latest version of SOLIDWORKS have just been using it to open files, maybe move some surfaces, add some material for post-processing, and then saving them out. And actually what we were just shown with the mesh editing and stuff is the first I've actually seen of that. So we will definitely be looking into using that. But what I've done is I've picked some examples of some more in-depth cases where we've had to actually design something. And so the scan to 3D functionality is something I'll go through. And also one of the other big benefits of additive is also mass customization. And so I'm going to show a bit about how design tables can help with that. So to take full advantage of 3D printing, a lot of engineers and designers are sort of required now to model in different ways. And typically what you might see being marketed by machine manufacturers and such is all these complicated, crazy parts where they're trying to exploit the geometry freedoms, like with topology optimization and porous structures and things like that. But as I mentioned, things like mass customization are also a big advantage of additive manufacturing. So our sweet spot is somewhere in between someone who wants a one-off and someone who wants to tool up and cast thousands and thousands of parts. We sort of sit somewhere in the middle. And because it's a relatively new manufacturing process compared to, say, traditional casting, forging, even machining, a big part of our job is education. And so that's why we have quite a talented team of engineers, because they need to know how to do advanced modeling and help our customers out when required. So let's just jump straight into the first example. The first example is a pretty interesting case where we got given this. Let me open it up here. We got given this file here, and this was from a veterinary surgeon. And the idea.
Peter, you are muted. We can't hear you.
Oh, can you hear me now?
Yes.
Hello?
Yep, we're good now.
Sorry. So the idea was that the veterinary surgeon came to us and wanted a custom bone plate made for a dog jaw, which had quite a significant injury. And normally we wouldn't take on a job quite like this, but we had an interest in this one. So we wanted to try and use the SOLIDWORKS scan to 3D functionality, which normally would be used with a, say, a laser or 3D scanner to reverse engineer something. But in this case, we used it to design something. So I'll show you what the end part looks like, and then we can talk about how we got to it. Basically, we designed this jaw implant, which is conformal to the dog's bone. So if we look at this image here, you'll be able to see that on the CT data, we've assembled this jaw bone on the healthy side that's not injured, and that's what we've designed it from. So there's, say, from the back surface of the implant, there's about 0.3 millimeters of clearance, so that it fits really nicely on the dog's jawbone. So the key here is to get some really, really good data into SOLIDWORKS and getting a nice mesh into SOLIDWORKS so that you can deal with it. So we got given a DICOM file, which is just a series of images, basically a CT scan. And then we needed to obviously extract the bone from that. So we can see the poor dog here, and then we were extracting the skull or the bone model from there. You can see it's got quite a severe injury here on one side of the jaw, and so we're using the healthy side as a reference for our design. What I would recommend whenever you consider using the scan to 3D functionality in SOLIDWORKS is that you really want to have clean data input. It's the old saying, I guess, of crap in, crap out. If what you put in is not good, you're going to have a bad time. And so effectively what we did is we did some work on the mesh to extract the part of the jaw we were interested in. So between the veterinary surgeon and us, we decided what part he wanted to fill up with titanium. So that's that center part here. And then we gave ourselves some references around the outside of where we were going to design the bone plate. So the first part was getting that mesh. So from the bone, we basically extracted the part of the STL file that we had got from the CT scan, and then we put that into SOLIDWORKS. We had already decided roughly where all the holes and screws were going to go, because we needed to avoid existing holes in the bones and nerves and things like that. So with the veterinary surgeon, we came up with a few different references. Something worth mentioning is if you ever need to deal with CT scan data, you want to make sure that when you threshold it, when you take away all the skin and tissue, that the bone, what you're left with, is the right size digitally. So we came up with a few different reference links that the vet could measure on the dog. This was one of them, which can be challenging, but something you should consider. Same thing for if you're doing reverse engineering. You always want to make sure that what you've modeled lines up. So in SOLIDWORKS, one of the cool features of Scan to 3D is when you bring in a mesh like this, it's not treating it as a graphics body or a surface body anymore. This does require the premium license though, so it's available under your tools and Scan to 3D. When you've got a model like this that is kind of a profile, then you can use something what's called the Curve Wizard. So if I just do a quick demonstration of that, we can show that section there. Go to our Curve Wizard, all the options come up under the mesh if you right click it. And you can actually just choose a plane. So if you've already set up your references, you can choose a plane to work from. Oh, over here. Select the starting point. And then what SOLIDWORKS will do with this feature is actually give you 3D sketches at certain intervals of your sections. And then in this case, we were able to just use.
Peter, you are muted again. Yep, try now.
Sorry, you back now?
Yes, you're back.
Righto. So that's a really quick and easy way to start getting a reference. So obviously live demo, this is not going to work that well, but what we ended up with is our CAD body. So I'll show you that one. Let's roll back to here. What we wanted to get was a body that had an offset from where the bone was, because we wanted some clearance in it. So this center section of mesh is where we wanted the implant to be, and then we wanted to set up some references to start actually designing from. So let's hide this mesh for now. And that's kind of what we were starting with there. So the key here, when you want to use a reference to model off of, is that this surface is all one surface. We've managed to get it so there's no split lines, and there's nothing wrong with it. So you'll see why that's really important moving forward. But because we wanted to do a conformal design, we wanted to be able to extrude from that surface. So when we went to go to design the plate, we'll rebuild that. Then what we can do is from that surface we created, from the scan to 3D functionality, as it extrudes right from that surface. So when you're extruding something, you've actually got an option to extrude from a surface, and that is right up here at the top of your extrude from, and we chose the surface that we had got from the 3D scan data. So that's the trick to making it conformal. And then from there, it was essentially your normal parametric design, but with a few tricks to get references in the right place. Now, the other thing that the vet wanted to do is put a porous region in the part. And this is quite common, and so I can show you the final outcome. It was a part that looked something like this, where we had the conformal implant that was going to fit in the jaw, and then a porous structure on the implant side that promotes ingrowth of bone through the whole implant itself. And so for that porous region in SolidWorks, we followed the same design process, but it's something we have to do quite a lot because customers quite often will come to us with a design and they're unsure how to add a porous region. And we have to use a separate software, obviously, to design that lattice structure. So if you ever send a file to us or another manufacturer, we want to have two CAD bodies, a solid one and a porous area, and then we can apply a porous design or structure to that second body. So in this case, we actually got the profiles, made them, and then moved face. So I can show you that there. Let me just show you that. So the surface loft was made up of all of the profiles, and then we moved face on that to make it a bit smaller. So we got the wall thickness that we wanted of solid, and then that's how we defined where the porous region would be with a few booleans after that. So that's a really interesting one, and in my opinion, it is, well, what was previously, this is obviously before the 2020 version of SolidWorks came out, but this was right on the edge of what you could achieve in terms of conformal designs in SolidWorks, because it's, because this is sort of right on the limit of what you can achieve with a parametric style design. And this part from edge to edge is just a tad over 40 millimeters long. So this is a very, very small component. It is also right on the limit of the sort of fidelity that our machines can build. Right.
Peter, you are muted.
All right.
Yes.
I should be back now.
Yeah.
The key here for any 3D scanning or reverse engineering is getting a clean mesh file. So previously I would have had to tell you that we did that in other softwares. In this case we did. But with the features you just saw with the mesh editing and mesh reduction and smoothing, that will make it a lot easier to use SOLIDWORKS as your reverse engineering software. Yeah. So the other benefit to, well, one of the other benefits to additive manufacturing is mass customization. So we have some customers that send us some files that are very similar, but they're all just a bit different. But they're not producing enough of these to sort of tool up, because they're only doing one or two off, and then it's a new geometry. And they're all pretty much the same part, but a bit different. So when you got something like that, that's when parametric design makes a lot of sense. And there's two sort of styles of design table or applications. And one is that you can have it control your geometry or your form or your shape. And the other one is just if you had a series of sizes. So I've got a couple of different demonstrations here. One of my colleagues, Andrew Chisholm, was really into climbing. And so he quickly made up this carabiner model to show the functionality of design tables. So some of you may have already used design tables before, that's okay. But we're going to show you how this one works. Essentially, we've got this sketch here that is defined by a whole bunch of variables. And I'm not going to go through exactly how to make that, because there's lots of really, really good tutorials online. But basically, all these lengths, angles, etc., are defined by variables. And in SOLIDWORKS, you can have different configurations in a design table. So this whole sketch in this model, and even the thickness of the profile, is defined inside of a Excel spreadsheet. And so when you open that up, you've got all the variables in your sketch, A, B, C, D, angles, cutouts, thicknesses. And so if you've got a customer that really likes to come to you often and just tweak the design a little bit, instead of spending quite a lot of time having to make a new model, recad something, it can be as simple as just a new line in a spreadsheet and making a new configuration. So for instance, we've typed in all these different values, and we can just roll through all of these different types of shapes of carabiner that someone might want. In this particular example, it's all constrained around one gate size, but you could also control that in the design table too. And I believe this, correct me if I'm wrong, but I don't even think that this is a premium feature necessarily, but it's very, very powerful. Another application where this is
standard license, yeah.
Yeah, right.
Yeah.
So that's a really powerful tool for the standard licenses design tables. Now, the other application we see a lot is customers that want to come in and they order something and then they want to just change the size of it. Oh, I want it a bit wider, a bit taller, a bit thicker, something like that. Or a different thread size or something like that. So I've got an example of here of just a simple part that has a porous structure in the middle and solid around the outside, and they always want a different height, width, length, angle, and all of that is defined in a table. So in our sketches, we've got a reference to our variables in our design table, and the beauty of this is that we also combine this with using macros in SOLIDWORKS, so VBA macros, and we've got some macros that I haven't got that on here, but we've got a macro that will run through and save a step file for every configuration. And so it's really as simple for us as going into the design table. If the customer decides they want a different size, we could come in here and go, okay, well, they want a 16 by 20. Oh, these aren't working. A 16 by 20 by 5. And we just type that in. Oh, not sure if I dropped out there, but make a new configuration, and we instantly can save out the model and we're ready to start processing that file. So that can be a real time saver if you've got the right application. So just quickly go back to maybe what it is that we do. Oh, one thing I forgot to mention earlier on the vet component was it's always really good when you're doing any sort of reverse engineering job to go back and validate that your surfaces compared to your reference are lining up. So one thing you might have thought is, oh, I wonder if that surface loft that he's made from those profiles is very accurate. Well, here we can see the CAD surface lined up to the CT scan, and so you can see it's within plus or minus 0.1, which for this application is totally acceptable. Yeah, so those are the two main things I really wanted to run through. So I might just go back to my presentation here just to discuss that. Here at Xenotechnica, we're production focused, so we are turnkey. We will take care of machining, polishing, all those sorts of post-processing processes, but we are very much focused on the metal 3D printing. And we've got full quality systems and inspection processes to do certified work if necessary. One of our main lines of work, our bread and butter, is patient-specific implants. That's really one of the things we enjoy doing. In terms of metal 3D printing on EBM, our typical tolerances are from 0.1 to 0.3 millimeters. And like I said, the porous structures, the mass customization and design freedom are the key benefits of additive manufacturing. And with batch sizes that are sort of in between a one-off and a mass production. We won't talk about that at the moment, but electron beam and laser metal 3D printing are both available in New Zealand. They both have their own applications. They're good at different things. So for instance, when I showed you at the start that when we build parts, they're filled up with sintered powder. So in this photo here, this very fine internal structure is not something we could do and remove powder from. So that's where laser printing would come into its own. However, there are some metallurgical benefits from electron beam mounting. These are some demonstration parts, some orthopedic implants, veterinary parts with porous structures, complex geometries, all the way up to a large exhaust manifold we built for a Koenigsegg engine. So for instance, implants, you might be looking at thousands of acetabular cups a year, and then for free valve or Koenigsegg, we built, I think, maybe 3 or 4 for their prototyping before they would have gone and cast them in production. So if you have any questions about any of that or the applications, feel free to email me, but I believe we're going to have a sort of question and answer section soon.
Yeah, so thanks, Peter. Thanks so much. So do we have any questions, guys? And is there anything else, Peter, you would add to the presentation, or that's it?
I think that's about it, actually. I just wanted to keep it short and sweet to the point. Yeah.
Sounds good. Actually, I learned a lot from it. Yeah, thanks so much. So in GoToWebinar, guys, there is a question section where you can write down your question. Yeah, and we'll get back to you now. So we'll give you a few moments if anyone have a question. Looks like the presentation was clear enough, Peter.
I hope so. Yeah.
Yeah, so looks like there is no question. So again, thank you so much, Peter, for your presentation. It was really useful. Yeah, and yep, I have a question here. How strong are source carbines? Can you see this, Peter, or not? That's fine. Excuse my pronunciation as well. I will try to copy it and send it to Peter. So Peter, basically, I can't hear you. Yes. So
Yeah, where's the question?
Nick has a question here. How strong are source carbines? Those carbines, carbiners? Yeah.
Oh, right. Yeah, I'm not going to pretend to be an expert in carabiners. My colleague designed those, so I was just showing the design table. Yeah.
Mm-hmm. I also have another question. Yeah, so Kenneth, yes, this is where you can ask your question. Please write it down. So I have another question, Peter, is what program did you use to convert the CT scan into an STL file?
Right. So there's quite a few different ways to do that, and there's a few different ways actually that you could have even designed a part. But I actually used, there's a really cool program called ImageJ, or in this case, it's called Fiji. You can give it a search, but basically we have a 3D scanning software called ATOS Professional, which is made by GOB, German company. And we use this for our blue light or laser 3D scanner. And it's a really, really powerful tool. And now, because we have that software and they also manufacture CT scanning machines, it can actually handle the import of raw CT scan data. So the only challenge going from the series of images in a normal CT scan is saving that out as a raw data file. So this program ImageJ is able to open an image stack or an image slice. You can even go ahead in here and actually visualize it. I assume you, sorry, and then you can sort of going while it's recording. Let's close that. So yeah, just saving it out as a raw file, importing it into this ATOS Professional software, and you can see here we've thresholded our poor dog there, what's bone and what's not effectively. There are other ways that you can do that, but that was the quickest way for us. Yeah, so that may not be very helpful because this ATOS Professional software we're kind of lucky we have it for other reasons.
Okay. There's heaps of other questions. Yeah, so Peter is asking a question here. Does SolidWorks Print to 3D have the level of functionality to compare with the likes of the simplified 3D? So Print 3D command that I presented at the beginning of this webinar is to facilitate printing directly from SolidWorks. And when you click on print properties, it will show you the configuration of your printer and some additional settings and permissions from your printer. But you can't do all of the functions exactly the same as using your printer software. Like for example, if you would like to combine several parts and do a particular quantity, all of this function is not available here. So Yeah, this function in SolidWorks is good enough if you have to print just one single part in a particular orientation. So there is no compare or there is no stuff like this. Yeah, maybe it will be developed in the new releases of SolidWorks. Hopefully this was clear enough, Peter. There is another question here from Kenneth. I think this one is for you, PT. What are the ballpark cost for parts? Example, if you are printing a titanium golf marker, are you talking about $100 or $1,000 or more?
Oh, sorry, could you repeat the first part of that question? That was about price, was it?
Yeah, so what are the ballpark cost for parts? Example, for example, if you are printing a titanium golf marker, are we talking about $100 or $1,000?
To be honest, if you want a price, the best thing to
You're muted. You're muted, Peter. Yep, we start
what you typically see. Oh, can you hear me?
now. Yes.
Oh, sorry. What I was saying is, if you want a price on a particular model you have, it's best to email it through to me and we can get you a quote. What I can tell you is that the price can be really sensitive to size. Effectively, the price is affected by sort of how many we could fit in a machine at one time and how big your batch size is. So yeah, best to email me through a model and we can get you a quote.
Okay, I have another question from Michael. Is hello, the waste incinerated material, does it add to the manufacturing cost, or can it be reused or only recycled? Excuse my spelling.
Oh, sorry. What was the first part of that question?
It's asking about the waste material. So does it add it to manufacturing cost, or will be reused or only recycled?
No. So we don't have much waste material apart from the support structures that we have to build underneath the part. And in EBM, because we're building in a sintered volume, those supports don't actually have to touch the plate. So we can float in 3D in the nest and the parts don't have to touch the ground. So there's very little waste. When we blast powder, when we blast away the sintered powder from the build, we do that in a powder recovery system. So it's full recycling of powder in the build. That goes back into the machine. It goes through a cyclone to remove any fines. It goes through a sieve to remove any large particles. And so it can be reused.
Perfect. Yep, thanks, Peter. Okay. Yep. Michael was telling you that answered his question. All right. So I'm able now to copy the question across to you, Peter. So if there's any question, yep, I will copy to your chat. Because I'm not familiar with all the terminology in your industry. Yeah. All right. So what other questions do we have, guys?
Yeah, I mean, one thing I'd say about the Printer 3D is we've seen a lot of progression from SolidWorks over the past few years, but being in the metal side of things it adds another level of complexity. So for instance, we spend quite a bit of time designing support structures. It's not like your sort of FTM 3D printing where it does it for you. We actually have to design the support structures that go on our parts.
So I believe Printer 3D directly from SolidWorks will never be useful in this process. It should be done within your printer application. Am I right?
For the time being, yeah, I think that's about it.
Yeah.
I have seen some add-ons for SolidWorks that are focused on metal 3D printing, so that could be something interesting. But yeah, mostly a concern for the manufacturer, I suppose.
I believe the basic idea behind Print 3D option in SolidWorks is to give the designers idea if this product fit or not in the print area. So you make sure that you are within the proper parameters. Yeah, so it's just a start. Then later on, maybe it will be developed to be way better.
Yeah, for sure. I mean, size is obviously a big constraint with additive manufacturing. So for instance, our small machine is a 200 millimeter cubed, and our larger machine is a 360 millimeter cylinder by 360 high. So that's the maximum component you'll fit in there. But there's also a whole lot of variety of metal 3D printing methods that will have different pros and cons as well. Material properties, geometry constraints. Yeah, so it's always good to get in touch with the manufacturer and actually discuss those.
Well, good. Any other question, guys? All right. It looks like Michael's question was the last one. Yep. All right. So thanks for your time today, guys, and thanks, Peter, for your presentation. It was very useful, and see you in our next webinar. All right. Yep. Cheers, guys. Bye bye.